Hi everyone, welcome back to the channel. Um, in this video, we're going to look at the next step in this tape out series that we did. So let's go ahead. If you go to my playlist on YouTube and open this playlist, you'll see that we did quite a bit already. We've set up cadence, we've done high frequency device characterization. We also introduced layouts in the last couple of videos. And we also saw how to extract the dielectric properties and metal properties from the PDK and how to use those to do high frequency simulations of, for example, transmission lines, right? But there are still two things remaining before we can actually start doing real layouts and real designs of different MMIC or RFIC designs. So that's what we'll cover. The first part we'll cover in this video, and then the last part in the next one. So what are these two things, right? So if you remember, if you go back and look at the designs of the transmission line that we did, so the layout that we did here was basically with a whole bunch of dummy layers, right? So if you look at the used layers, we used a lot of dummy layers. Only metal 11 was the real metal. So the rest of it was dummy layers so that we could export this to HFSS and do simulations there. So today what we'll do is we'll see how we can replace these dummy layers with real metal layers so that they are all DRC clean. And that's where these layout blocks kind of come in, right? So that was the first thing. So we'll create some metal grids that are DRC clean and that can replace these metal layers. So once we create the metal grids, then comes the last step, which is if you go to the tech file that we created, we saw how we can extract the dielectric constant and metal conductivity and loss tangent. Did we do loss tangent? No, we just did the conductivity, elevation thickness, and dielectric constant, right? So anyways, so we saw how to do it for all of these materials, but we still have not done it for the metal stacks, right? M1, M8, and M1, M11. I said I'll do it later, and that's what we'll do next. So first we need to create these metal stacks and these metal grids of M1, M8, and M1, M11, sidewalls and ground plane basically. And once we have these metal grids, then we can go ahead and extract their conductivities. So in this video, that's what I'm going to do. I'm creating these metal grids, and also I'll show you how to create some other layout blocks. Okay, so let's go ahead and start. I'm going to close this. So we'll create a new library, call it AVM layout blocks YouTube. And then obviously we attach it to the GPDK. Okay, that's good. Don't know what this is. It seems like Cadence is having a bug. So let me just restart Cadence. Right. So here I've created a new library called layout blocks, and we'll start creating some simple metal grids. So let's do that. Let's say new cell view. I'll only create one metal grid, and then I'll share a GDS file of all the other metal grids that you can import. So let me actually show you how to do that. So in case you're curious, you can go onto my website and the GDS file is already uploaded here. I'll show you how to download this and import it so that you don't have to do all these drawings yourself. But I thought I'll show you one drawing just to show you how you can do it to get kind of familiar with drawing these things. Okay, so let's do layout and I'll call this AVM, my initials basically. We'll do from M1 to M11. That's the sidewalls of the transmission line. I'll do a 5 micron by 5 micron grid, and I'll call this version 1. Okay. All right. So we can get started. So let's do routing layers. I'll create M1 and I want to make a rectangle. So I already went through the hotkeys and stuff for layouts. I'm not doing it again. Hopefully you know how to do layouts so you can, if you already watched that, it should be fairly straightforward. Okay. So let's draw a rectangle and I'll say this goes from minus 2.5 to 5, 5, 5. Okay, there we go. So that's in M11. And then I want to make some cuts in this. So I'll use the cut tool, turn on gravity first. Okay. And then I will create a cut of size 1.5 and minus 1.5. Okay. Then I'll make another cut from here. 5 minus 5. Oh, oops, that's too big. Okay, same thing from the bottom. Okay, so once we've made one layer, we can go ahead and make the other layers. So in the top metal, I want to have a plus and then a square in the metal below that. So let's go to metal 10 now. And then what I'll do is I will make uh, square here. Okay, so then I want to move this till here, down. I can align these two using the align tool. And then another one that is 1 and minus 5. And then minus 1 and minus 5. Okay, so now that we have a square, we can merge these layers. So we have a square and a cross, right? So that's what we'll do. We'll alternate between these squares and crosses. So this is metal 11, metal 9, metal 7, metal 5, metal 3, metal 1. So let's rename them or reassign them to metal 1. Sorry. This should be metal 1. This should be metal 3. This should be metal 5. Make this metal 7. And then metal 9. Okay. Oh, sorry, that didn't get assigned. Metal 9. And then the cross the squares, 10 is 8, this is 8, this is 6, 4, 2, right? So let's make this metal 8. This should be metal 6. This is metal 4. And this one is metal 2. Okay, so we want to bring them back on top of each other, and you can do that easily using the align tool. We're using A, as we discussed in the hotkeys video. Okay, so they're all aligned. Bring these back. That's it. Okay, so let's go through them. So you can see we have metal, let's go from the bottom actually, metal 1. And then if I just drag, you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, right? So you need to make sure they're alternate, right? So you can even look at it like this, then this, and this. Okay. Now we need to add vias to connect them in these four, on these four edges. So that's simple. Just say I want a via, and then I want a stack via from metal 1 to metal 11. And I'll say I'll draw over an area to get the stack. And the way I'm going to do this, I will draw it from this corner, not all the way till the edge. I'll leave some room there. Okay, so that's that. Just make them all visible. Hit Shift F. That creates the via. The reason I left some room is because you want to make sure if you're too close to the edge, then you'll get a DRC error because this via will be very close to its copy when you make a copy of this grid on the right. And you kind of make copies of this grid. So that's the reason I'm doing it like that. Okay, and then I can rotate it when I'm moving it. If I click the center mouse button, it rotates stuff, right? So I can bring that there. And then I'll align it with this edge. And then make some more copies. I will move it. Let's align this. Let's align this corner with this corner. Oh, sorry. It's not that. I want to align this corner with this line and this line with this. Okay. And then lastly on the bottom, find this corner with here, this line with this. Okay. That's pretty much it. So that's a nice 5 by 5 grid. You can see that the spacing is correct. So you can go from here to the end, it's 2.5 and so on. All right, so this is just how I've made one grid. So what I'll do is I'll go ahead and make a few more that we'll use to make the transmission line, and I'll come back and show you so you don't have to actually go through all of them. So let me just quickly do that. I'll come back. Okay, so I made a few grids that we'll need. So the best way to kind of see what they are is to actually put them into a single location. So what we'll do for that is create a new layout called AVM all blocks. And this I you like to do it this way because it's also easier when you're actually doing final layouts to just pull everything from one location and to see them visually. Okay. So we'll make a new place called a new cell called AVM all blocks, and then I'll import all of these layout blocks one by one. So this is a 1 by 1 as a mosaic, I guess. Uh, the size of this. This is actually, no, this is not mosaic. This is just 1 by 1. Okay. And then that's 1 micron by 1 micron. And then I made block that looks like this. Made another block that looks something like this. That's the M1, M8, right? And then this one. I'll show you what the difference between all of these blocks is. Another 5 by 5. Then we have the one we just made in this video, which is this one, and then two variations of it. Okay, there we go. So these are the ones that I've made so far. Let's go ahead and make a transmission line using them. Then you'll see what they are. Okay, so it's the easiest way to do this. Okay, let's actually do it this way. So I'll put this one in the middle, and then I'm going to put this one next to it. It's ground plane. Copy on the other side, line it. And then comes this guy. So I'll show you what these are. Don't worry about that right now. Okay, so once I put this, then I'm going to copy this block here, line it that way, make another copy on this side. And then I want to flip it so I can actually go in here and click this. And then I'll align to this corner. And then lastly, we'll use the block we just made. Side. Okay, that's good. And then lastly, I want to open metal 11 and make the top metal layer, the center conductor of the GCPW, which goes from here to here. Okay, so this is essentially now our transmission line. So what I will actually do is make a new cell in the layout blocks. Cell view. I'll call it AVM GCPW straight line. And yeah, that's it. Okay, and then I'll actually copy this over there. And I have to center it correctly. Okay, let's see how centered this actually is. Off by 0.5 and by 0.135. Okay, so let's fix that. So it needs to move down by 1 and to the right by 0.15. Okay, let's clear those markers and try again. So that's the center line. Let's see, from the center line to there, it should be exactly 2.5. That's good. And then, of course, this is also, no, it's not aligned. Oh, sorry, I moved it too much. So 0, 0. Okay, now it's aligned, right? All right, so the reason I'm making a new block is that in this sort of top level where I put all of my blocks, I don't want them to be in pieces like this. So now we'll go ahead and we'll import it from here. Now I can make it a mosaic. Example, I can make this 10 rows or 10 columns. Oh, sorry, should be 10 rows, not 10 columns, right? Okay, so I'll place my line now and let's take a look at the line now so you see what it looks like. So on the top metal, I have my center conductor and a wall on the left and right. Right, and this wall is full until at least a depth of about 3.5 microns. That's more than enough, really, to create a good wall. And anyway, it's connected after that with some holes, but that's what it is. Then if we look one layer below that, we have sidewalls. One layer below that, again, sidewalls. And then one layer below that is the ground plane, the top layer of the ground plane, right? And you need to make sure that you don't have to do this, but I kind of like to do it in such a way that the ground plane underneath the center conductor is full and there are no holes there because most of the current actually flows in the right underneath the center conductor. So that's why I have it like that. And then the same for the layers underneath, as you can see. And these are all connected. So M1, M8 is all connected underneath the ground plane. Right? And that's essentially my transmission line. So now if you want to compare this with what we made earlier, let's go ahead and do that. So the transmission line that we made was something like this. I don't want to make a mosaic, right? Can put it on top of this. There we go. Right, so they're actually very similar. I mean, maybe hard to see this here, but let's actually do this right now. So what I will do is I'll make a copy of this to the new layout blocks, and I will call it AVM GCPW straight high frequency. So this is a high frequency version of it, which means that it doesn't have all the grids. It just has a couple of layers that it needs to have. So let's open that up and I'll delete all these layers that we used for the dielectrics and the metals and the airbox. So all I want is now the center conductor, the ground plane, and then the side walls, right? So if we use the dummy layers, we see we only have the two metal stacks. This metal stack, which goes to M1, M11, and this metal stack goes from M1 to M8, right? So we'll save this and let's import that now. So we go to layout blocks and we look at the high frequency version. Okay, so there we go. So you see the comparison between the two and hopefully now it makes sense what's going on, right? So we have a high frequency version, which we send to HFSS to simulate, and we have an actual version that we use to do our layouts so that it's DRC clean. So how do you know it's DRC clean? So let's actually go ahead and run the DRC check. I also made this other layout block here, which we'll use later. Actually, I'm going to delete this. So we'll use this later when we want to make right angle bends. We don't need it right now. So let me just delete that for now. That block is not DRC clean. That's why I'm deleting it. Okay, so let's run DRC now and see what we get. Okay, so let's make a run directory. We already had one DRC run directory. And rule file was from PDK. We already discussed this before, so I'm kind of going through it quickly. Okay, that's it. So let's submit, save it. Let's look at what DRC errors we have. Okay, so there are some DRC errors. So let's see what they are. So it says the spacing metal 2 to metal 2 spacing. Let's take a look. Be greater than 1.25. I mean, yeah, I guess I placed them too close to each other. Spread them out. Okay, so let's run this again. Okay, so it's clean. The only error that we have is saying that P substrate is missing. And that's fine because we don't have any actives right now. When you do a final design, that'll be fixed. All right, so this whole thing is DRC clean. Um, and of course, it's highlighting the whole area with P substrate error. Just close it. All right. Okay, so now that we have this done, I just want to show you something really quickly, which is I've already exported this GDS file, so you don't have to actually draw all of this yourself. So let me show you how to import that, right? So what you have to do is go onto the website and then click on this link, and then you can save this GDS file. So save it in your, whatever folder you like. So for example, for me, it's in my Cadence folder, avmallblocks.gds, right? To import it, what you need to do is you need to make a new library. So I'll call this AVM layout blocks temp, temporary library. Hit OK, and then attach it to GPDK. Right, so we have a new library, and now what you want to do is go in here, say File, Import, Stream, and then here you'll select the stream file, which is the GDS file, which is this one. Hit Open. Go to Library and click the library that we just made, Temp Library, and you have to specify a top cell. So here we'll specify the top cell as the name of the GDS itself. And that's what you should do. AVM all blocks. View is layout. We don't need a template file, and you want to attach it to GPDK. Okay, and then hit translate. And it'll give you two warnings, whatever, you can ignore those. All right, so now we have this temp file. You should have all of these layout blocks. So if you go in here and open it, I in fact have the same thing, except that it's slightly different because I did this before. I've also created a label uh, showing that this is the transmission line and these are the basic building blocks that we're going to use. Okay, so I would recommend you go ahead and actually go through all the layers and see what I've actually done here to get all these layers and how to get the different sizing and things like that, right? It's important to go through that. And as we go forward, we'll build more and more of these layout blocks when we need to, based on the design. So we also need a separate bunch of layout blocks for, routing and biasing, things like that for power handling. Um, so as we go through, we'll build more and more. But that's the basic idea of how to go about it. Okay, so that's pretty much it. That's all I wanted to cover. So you can download that file and then import it, and then you can see how I did it, or you can draw your own if you like, whichever way you like to go about it. All right, so now that we have this ready, in the next video, what I'll show you is how to use these grids that we've made and calculate the equivalent conductivity of these grids, right? That's the last piece of the puzzle that we need to finish everything, all the basics all the tools that we need to do real designs. Just to recap, that's for the tech file, right? We need to know what the conductivity. So now we know what the grids are for M1, M8 and M1, M11. Since we now have the grids, I'll show you how to calculate the conductivity of the effective conductivity of these grids. Okay, so look forward to that video. If you have any questions, you can leave them in the comments. If you have any other suggestions, happy to hear that. Okay, thank you so much. See you in the next one.